You walk through a storm, hold your head up high.
Assalamualaikum. My name is Abu FAHMI. I represent Liverpool Group. The topic of the journal that we will discuss is thermodynamic analysis of a steam power plant with double reheat and feed water heater. I will give a history about the steam power plant and introduction about this journal. History. The steam power began with Thomas Newcomen in the early 17th. Early development were very slow, and Newcomen design was used in England for nearly 100 years. Newcomen engine could be better described as a vacuum engine. The vacuum was created by condensing steam. The engine, however, was extremely inefficient and work could had to be brought from a distance. It was expensive. Introduction. Steam power plants are widely utilized throughout the world for electricity generation, and coal is often used to fuel this plant. Energy consumption is one of the most important indicators showing the development stage of country and living standard of communities. Currently, 80% of electricity in the world is approximately produced from fossil fuel via thermal power plant, whereas 20% of the electricity is compensated from different sources such as hydraulic, nuclear, wind, solar, geothermal, and biogas. From this journal, the energy and exergy analysis are conducted to evaluate the performance of the above suggested steam power plant circle using 6 closed-feed water heater with double reheat and with different extracting pressure.
Assalamualaikum. My name is Muhammad FAIS bin Muhammad YUSOF. My metric number is B0419100083. I'm from Group Liverpool, and I will explain about the schematic drawing. So we can see the figure 1 show the schematic of steam power plant cycle. In the present of study, the energy and the exergy analysis are conducted to evaluate the performance of steam power plant cycle using 6 closed feed water heaters with double reheat and with the different extracting pressure. The cycle involved with high pressure turbine HP, intermediate pressure turbine IP, and the low pressure turbine LP. The flow start from the condensate extraction pump, which is CEP, then enter the first, second, and third low pressure heater. Then it flow into the deaerator and feed water pump FWP. The flow continue with first, second, and third high pump heater before entering the boiler. From the boiler, the process will enter to the high pressure turbine, and the flow will enter to the boiler bag. This process will repeat with intermediate pressure turbine IP and low pressure turbine LP. After this process complete, the last process is from low pressure turbine LP. It will flow into the condenser to complete the cycle for this study. So that's all. That's the flow process of the cycle of schematic steam power plant. Thank you. So the other part will be explained by my friends. Thank you.
Hi, Assalamualaikum. My name is Muhammad ASHRAF bin ABDULLAH. In this video, I will explain a little bit of what I'm studying from the journal. For this part, I will explain about the method used for the performance analysis. The main method used for the performance analysis is the equation, the table, the chart, and the figure. These are the most important methods for the performance analysis. First of all, I will explain about the most important method, which is equation. For an example, an open system at steady state, the first law thermodynamic equation used in this journal. So let me continue to the next important method, which is the table. The table is so important because we can get the value, performance, energy, and exergy. As for an example, the table in this journal show the parameter of the cycle. We can see the table given in this journal. Next, we proceed to the next method for the performance analysis, which is the figure. The figure is the important method to define value or to show the value. In this journal, it gives the figure about the TS diagram. We can see an example from this journal. It gives the figure 2, which is about the TS diagram of the cycle. Last but not least, the method in this journal is line chart. The line chart is used to differentiate and compare the value. For an example in this journal, it shows the effect of condenser pressure on the boiler and condenser heat looks at PB equals to 500 Celsius, 550 degree Celsius and 600 degree Celsius. We can see an example from this journal, the figure 3, the effect of condenser pressure on the boiler and condenser heat. So the method used for the performance analysis is so important. We can see the method in this journal. So that's all from me. Thank you.
Assalamualaikum, my name is Ahmad NAJMI and I will continue from my part, that is performance calculation of the system. To perform the calculation of steam power plant with double reheat and feed water heaters, the energy and exergy analysis can be applied on the system. Firstly, let me introduce what is exergy. Exergy defined as the maximum work that can be achieved by bringing a system into equilibrium with its environment. So the exergy analysis is one of the useful method and most applicable tool for thermodynamic analysis to perform calculation on the system. Okay, so this both equation show in general what is exergy discharge and exergy at any state of an open system, where EXQ, EXW, and EXD are the corresponding exergy of heat transfer work and the exergy discharge. Next, to perform the calculation of the system, D is the main parameter for all components of the cycle. And this is the first, second, and third equation to show the performance, energy, and exergy discharge for the first adiabatic low pressure feed water heaters. Okay, this is the result for the low pressure turbine. And the second one equation show the first, second, and third adiabatic high pressure feed water heater, and this is the result. And finally, this is the equation for the boiler. From all the equations show, energy efficiency can be defined as is, and this is for exergy efficiency, which is can also defined as is. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is ABDULLAH bin AZIZ. Today, all of you can see that there are many electrical generating utilities are striving to improve the efficiency at their existing thermal electric generating session. So, I will suggest the best solution to improve the system. For the first is increasing initial steam parameters, which is the temperature difference between the heat and cold sources determine the limit of the efficiency of heat engine. As discussed above, the efficiency of thermal power plants could improve by increasing the initial steam parameters. High volume, high parameter supercritical and ultra supercritical thermal power plants have proven stable and effective for large scale commercial power generation. Supercritical power plants can attain an efficiency 2 until 3% higher than subcritical power plants, while ultra supercritical thermal power plants boast an efficiency even 2 until 3% higher. For a second, lowering final steam parameters. Given a fixed set of initial steam parameters, lowering the final steam parameters would allow for a greater temperature difference between T-steam and T-condenser, thus lifting the theoretical efficiency threshold for thermal power plant. In a thermal power plant, condenser is the place where the waste steam is condensed, after which the water will be pumped back into the boiler. As we know that the most modern thermal plants use either water-cooled condenser or air-cooled condenser as the cold source in the cycle. Water-cooled condenser could be classified into cooling system with open and closed system. Air-cooled condensers could be classified into direct or indirect cooling system. For the last is water preheater. In the water preheater, the expanded steam is extracted from the turbine under certain parameter, which is used to heat the water before pumping it into the turbine. In such a system, energy from extract steam is transferred back into the system, where the cold source loss would be much smaller than a simple Rankine cycle. Furthermore, the extraction consists of several stages, where the longer the extraction from the turbine takes, the lower the temperature of water for heating. In this way, steam could do more work on the turbine before getting extracted, thus increasing the thermal efficiency of the turbine. Each turbine has a distinct set of optimal steam extraction parameters. Theoretically, the more stage involved in the steam extraction inside the power plant, the higher the total efficiency of the power plant would be. In this study, we can conclude that the thermodynamic analysis of reheat Rankine cycle steam power plant with 3 high pressure feed water heaters and 3 low pressure feed water heaters with generator is conducted. In terms of the first law of thermodynamic analysis and the second law of thermodynamic analysis, the main conclusion drawn from the present study are summarized as follows. First, when condenser pressure increase, the condenser rejected heat increase and the turbine power, and then the first and second law efficiency decrease. But boiler heat transfer is independent of the condenser pressure. Second, as the high pressure turbine increase, the first and second laws efficiency have similar profile with maximum value depending on the high pressure turbine and the boiler temperature. Third, the maximum first law efficiency are obtained for the optimal extraction pressure at high, intermediate and low pressure turbine as 49.15%. And for the last, the maximum value of energy loss occurs in the boiler followed by the turbine, and the minimum value of energy loss occurs in the condensate extraction pump. Thank you.